We've all heard the debate, right? Which is cheaper, renewables or nuclear? Well, a recent study just threw a massive curveball into that whole conversation. It proposes a new way of measuring the cost of energy that could, honestly, change the entire game.
So let's start with the headline that got everybody talking, this absolutely massive price drop.
A recent peer-reviewed study found that a future energy system powered by a mix of renewables is a staggering 53% cheaper than one powered by new nuclear. I mean, that's a huge number, and it really demands a closer look.
Which, of course, leads to the big question, how can the price difference be that dramatic? Especially when we're always talking about the challenges of renewables like wind and solar. Well, to answer that, we actually have to completely rethink how we calculate cost in the first place. So here's our game plan for this explainer. We've seen that 53% claim. Now we're going to look at why our old price tag is incomplete. Introduce this idea of a total system cost. See how it plays out in a real-world case study. Uncover the secret ingredient of sector coupling, and finally, dig into what this all means for our energy future.
All right, so the most important point is this. The way we've traditionally compared energy costs has a pretty fundamental flaw. It's kind of like we've been looking at an incomplete price tag this whole time.
You see, for decades, the industry standard has been this thing called LCOE, or the levelized cost of energy. It's a pretty simple metric. It just tells you how much it costs to produce 1 megawatt hour of electricity at a specific power plant, whether that's a solar farm or a nuclear reactor. Think of it like this. LCOE is basically just the sticker price of a car. It tells you the cost to buy the car itself. But does that tell you the full story? No way. It completely ignores the cost of fuel, insurance, maintenance, all the real-world costs of actually using the car. LCOE does the exact same thing for energy. It ignores all the extra costs of integrating that power into the grid. And this is where a new approach comes in. Instead of just looking at the sticker price, we need to look at the total cost of ownership. We need to look at the total system cost. So the study, which was led by researchers at Aalborg University, proposes a new metric called SLCOE, or System-Based Levelized Cost of Energy. Now, the key here is that it measures a technology's cost within its energy system context. It's not just looking at the power plant by itself. It measures its cost as part of the whole shebang. So what gets added to the price tag? Well, SCOE includes all the extra costs needed to balance the grid when the sun isn't shining or the wind isn't blowing. It includes the cost of energy storage, and, this is crucial, it includes the value you get from something called sector coupling. Basically, it finally gives us the total cost of ownership for our energy choices. Okay, so this isn't just theory. To actually test this new metric, the researchers applied it to a real-world scenario, a case study in Denmark. They built out this incredibly detailed model of what Denmark's future climate-neutral energy system would look like. Then, they ran hourly simulations to see what the true total system cost would be for different energy sources in a fully integrated grid. And here it is, the big reveal. When you measure the full system cost, the SLCOE, the numbers are just, wow. For nuclear, the cost comes out to about €100 per megawatt hour. But for the cheapest mix of renewables, so that's combining offshore wind and solar, the cost plummets to just €46. That is the 53% difference. This one chart shows why looking at the whole system changes absolutely everything. So what is the secret ingredient that makes renewables so much cheaper at the system level? It all comes down to one really powerful concept: sector coupling. Sector coupling is just the idea of intelligently linking our electricity grid with other parts of the economy that use energy, like heating for our buildings and fuel for transportation. This creates this huge, flexible network that can absorb and store energy in really smart ways. So what does that actually look like? Well, imagine it's a windy, sunny day and you're producing tons of cheap, excess power. Instead of just wasting it, you can use it to heat water for entire city districts. You could use it to create clean hydrogen for industry or for heavy transport. Or you could use it to intelligently charge millions of electric vehicles, basically turning them into a massive distributed battery. It's this flexibility that just dramatically lowers the total system cost. Okay, so let's zoom out for a second and talk about what this means for the bigger picture. What's really fascinating here is that the study was actually pretty conservative. For example, the researchers used solar cost estimates for 2050 that, well, are already being beaten in today's market. They also completely left out the massive future costs of storing nuclear waste, and they didn't even factor in the opportunity cost of spending a decade or more building a nuclear plant. The real cost gap could be even wider.
You know, one of the study's co-authors, Professor Christian Breyer, he really put it perfectly. He said, "We document how essential it is to include the whole energy system in the search for least cost solutions. If you only look at the electricity sector in a vacuum, you're just not going to find the best, cheapest answers."
And that leaves us with a final, and I think really crucial question. For decades, we've been comparing the sticker price of our energy options. But as we try to build a clean energy future, this study forces us to ask, are we finally starting to measure what truly matters?